you need to know about Agnathan. Agnathan, without jaws, is a jawless fish superclass in the phylum Chordata, subphylum Vertebrata, that includes both living, cyclostomes, and extinct, conodonts and ostracizer species. The group is related to all vertebrates with jaws, which are referred to as gnathostomiaces. Recent molecular evidence, both from Riran and Medina, as well as embryological data, substantially support the notion that the cyclostomes, or live agnathans, are monophyletic. The first fossil agnathans emerged in the Cambrian period, and two families of agnathans still exist today, lampreys and hagfish, with a total of around 120 species. Because hagfish lost vertebrae secondarily, they are classified as members of the subphylum Vertebrata. Before this event was inferred from molecular and developmental data, Linnaeus created the group Crania, which is still sometimes used as a strictly morphological descriptor to refer to hagfish plus vertebrates. While some scientists believe that the living agnathans are only superficially related and that many of these similarities are likely shared basal agnathan characteristics of ancient vertebrates, recent taxonomic studies clearly show that hagfish, the myxine or hyperon, and lampreys, hyperon, are more closely related to each other than either is to jawed fishes. Let us take a look at the agnathan skeleton. Morphology. Aside from the lack of jaws, contemporary agnathans are distinguished by the absence of paired fins, the existence of a notochord in both larvae and adults, and the presence of 7 or more paired gill pouches. Lampreys have a pineal eye that is sensitive to light, homologous to the pineal gland in mammals. All Agnatha, both alive and extinct, lack a recognizable stomach and appendages. Both fertilization and development are external processes. In the Agnatha class, there is no parental supervision. The Agnatha are ectothermic, are cold-blooded, having a cartilaginous skeleton and a 2-chambered heart. 1. Body covering. Skin covers the body of contemporary agnathans, with no dermal or epidermal scales. Hagfish have many slime glands on their skin, which act as a defensive mechanism. The slime can occasionally block opponent fish gills, causing them to perish. Many extinct agnathans, on the other hand, had large exoskeletons made of either huge, heavy dermal armor or tiny mineralized scales. 2. Appendages. Almost all agnathans, including all extant agnathans, lack paired appendages. However, the majority have a dorsal or caudal fin. Some ancient agnathans, such as osteostracans and Pitoria's pids, did have paired fins, which their jawed relatives inherited. Metabolism. Agnathans are ectothermic, which means they do not control their body temperature. Agnathan metabolism is sluggish in cold water, thus they don't need to consume much. They lack a separate stomach and instead have a lengthy, more or less homogeneous intestine that runs the length of their body. Lampreys consume other fish and animals for food. Anticoagulant fluids are injected into the host to inhibit blood clotting, leading the host to produce more blood. Hagfish are scavengers who mostly consume dead animals. To break down the animal, they use a row of sharp teeth. Because agnathan teeth cannot move up and down, their dietary options are limited. Reproduction. Lampreys are fertilized externally. The mode of fertilization in hagfish is unknown. External development is most likely occurring in both groups. There is no evidence of parental care. The reproductive mechanism of the hagfish is poorly understood. Hagfish are thought to lay just 30 eggs throughout their lifespan. The majority of species are hermaphrodites. There is relatively little of the lamprey's larval stage present. Lampreys can only reproduce once. The lamprey's cloacas stay open after external fertilization, allowing a fungus to enter their intestines and kill them. Lampreys reproduce in freshwater riverbeds by building a nest in pairs and burying their eggs about an inch beneath the substrate. Before becoming adults, the hatchlings go through 4 years of larval growth. Class Agnatha characteristics. Chordata is a phylum. Vertebrata is a subphylum of the phylum Vertebrata. Digestive system. There is no recognizable stomach. Jaws are missing. Paired fins are almost often missing. The skin of early animals possessed thick bony scales and plates, but they are no longer present in current species. The skeleton is usually cartilaginous. The embryonic notochord survives until adulthood. There are 7 or more paired gill pouches. Evolution. Despite being a tiny component of contemporary marine fauna, agnathans were dominant among early fish in the Paleozoic. 2 early Cambrian animals with fins, vertebrate musculature, and gills have been discovered in China's Moshanshan shales, Haikuchthys and Mylocomingia. Janvier has provisionally placed them in Agnatha. Haikowella is a third potential agnathid from the same area. Simonetti identified a potential agnathid from British Columbia's Middle Cambrian Burgess Shale that has yet to be properly described. Many Ordovician, Silurian, and Devonian agnathans had thick bony spiky plates as armor. The earliest armored agnathans, the ostracoderms, are known from the Middle Ordovician, and by the late Silurian, agnathans had achieved the pinnacle of their development. The majority of the ostracoderms, including the lodonts, osteostracans, and gale aspids, were more closely related to gnathostomes than to the surviving agnathans, known as cyclostomes. Cyclostomes appear to have diverged from other agnathans prior to the emergence of dentine and bone, both of which are seen in numerous ancient agnathans, including conodonts. Agnathans went extinct during the Devonian period and never recovered. Invertebrates, two forms of recombinatorial adaptive immune systems, AISs, evolved some 500 million years ago. Although jawed vertebrates diversify their repertoire of immunoglobulin domain-based T and B cell antigen receptors primarily through J gene segment rearrangement and somatic hypermutation, none of the fundamental ICE recognition elements found in jawed vertebrates has been found in jawless vertebrates. The ICE of jawless vertebrates, on the other hand, is based on variable lymphocyte receptors, VLRs, which are produced by the recombinatorial use of a wide panel of extremely varied leucine-rich repeat, LRR, sequences. In lampreys and hagfish, 3 VLR genes, VLRA, VLRB, and VLRC, have been discovered and are expressed on 3 different lymphocyte lineages. VLRA plus and VLRC plus cells are T-cell-like and form enthymoids, which are lymphoepithelial structures similar to the thymus. VLRB plus cells are B-cell-like, originate in hematopoietic organs, and differentiate into plasma cells that secrete VLRB antibody. Class Agnatha classification. The lampreys and hagfish are the 2 primary groups of extant agnathans. Both have the appearance of a fish or an eel. Lampreys are parasitic organisms that adhere to fish hosts with sucker-like jaws. They touch the flesh of their prey with the numerous teeth in their jaws and on their tongues. Adult lampreys live in salty marine environments but swim up rivers to spawn in freshwater. Lampreys reproduce just once in their lives, in a massive reproductive burst, and die soon after. Lampreys go through an immature larval stage before becoming adults. The larval lamprey lives exclusively in freshwater. It develops and matures for several years before metamorphosing and moving to saltwater environments. It was assumed that the larva was a different species before it was discovered that it was a larval lamprey. The larva is of special interest to biologists studying vertebrate evolution because it has several characteristics with the cephalochordate branchiostoma, previously known as Amphioxus, which is thought to be the most closely related to vertebrates. The remarkable similarity between branchiostoma and the larval stage of a very early vertebrate suggests the tight connection between the 2 groups. The hagfish is the second group of extant agnathans. Hagfish are scavengers that eat dead and injured creatures in the water. Hagfish are also well known for their defense mechanism, in which they spew large volumes of nasty slime when threatened. According to the fossil record, agnathans reached their pinnacle of variety between 500 million and 340 million years ago. They were abundant both in the oceans and in freshwater environments throughout this time period. There are around 200 fossil species known. The bulk of these species were rather tiny, measuring just a few inches in length. The species that have survived to the present are only the remnants of a far more varied group. Agnatha facts. Hagfishes are found in cold seas all around the world, ranging from shallow to 5,500 feet deep, nearly 1,700 meters. Hagfish may go several months without eating. Hagfish have the ability to absorb nutrients directly via their skin. They are sometimes referred to as slime eels. However, they are not eels. They belong to the Agnatha class, which includes fish lacking jaws. Despite their lack of a jaw, hagfish have 2 rows of tooth-like keratin structures that they utilize to dig deep into corpses. They may also bite off food pieces. They twist their tails into knots when devouring carrion or live prey to produce torque and boost the power of their bites. According to a 2011 report from the International Union for Conservation of Nature, 12% of hagfish species are at risk of extinction. 1 hagfish species is severely endangered, 2 are endangered, 6 are near threatened. and 2 are threatened. Nobody knows if hagfish are a separate animal group that bridges the gap between invertebrates and vertebrates, or if they are more closely linked to vertebrates. The sole known fossil hagfish, dating back 300 million years, resembles a current hagfish, prompting some experts to assume that it has altered little since then. It's an indicator that they haven't stalled or stopped developing, but that they have arrived at a body plan that is still extremely effective today, says Tom Munro, a fish biologist at the Smithsonian National Museum of Natural History. Hagfish generate slime to fight off predators and other fish attempting to take their food. When they are agitated, the glands lining their bodies produce stringy proteins that expand into the translucent, sticky material when they come into contact with seawater. According to popular hagfish legend, they can fill a 5-gallon bucket with this stuff in a matter of minutes. When assaulted by predators, this slime provides a slick escape for hagfish. A bigger fish searching for food instead gets a mouthful of slime, whilst the hagfish can slip away. Agnathans are devoid of an internal skeleton formed of turay bone. The internal skeleton, like that of sharks, another ancient group, is largely made of cartilage.